Hello students, welcome to Understanding Quadrilateral Class 8 Maths, Chapter number 3. To understand the understanding quadrilateral, let's start understanding the basic concept of geometry, which started from a point. You know that point we may say that this is the basic unit of any geometrical shape. That means when you are drawing any geometrical shape or any shape, this is the sum of infinite number of points. Now, point has no any shape, size or any dimension, but when there is a continuous series of points are joining together, they form a curve. This is a straight line. It is also a curve. This is also a curve. This is the sum of infinite number of points. So what are curves? Curves are the continuous smooth series of points. When joined together, they form a curve. Now the curve may be open, may be closed. This is a open curve, but this is a closed curve. This is open curve, but this is a closed curve. Now, what do you mean by simple curve and not a simple curve? Let us take one example. This is also a curve, but the curve is intersecting itself at a certain point. So this is not a simple. When the curve is not intersecting itself at any point, this is a simple curve. So these are the simple closed curve. This is a simple closed curve. This is also a simple closed curve. These are the simple closed curve. Now let us discuss about the more simple closed curve, which is a polygon. Now what do you mean by polygon? Polygon is a simple closed curve made up of only line segments. These are the simple closed curve made up of only line segments. So this is not a simple closed, it is a simple closed curve, but it is not a polygon because it is not made up of all the line segments. This is not a line segment. Here all 3 are line segments, here all 4 are line segments, here all 6 are line segments. So these are the polygons, but this is not a polygon. Let's discuss now which are polygon and which are not polygon among these figures. These are the polygons because there is a simple closed curve and made up of only line segments. But this is not a simple closed curve because the curve is intersecting itself, here also intersecting, and it is not a closed. So these 3 figures are not polygon and these 3 figures are polygon. Now let's discuss about the different type of polygon: convex polygon and concave polygon. Convex polygon means these are the convex polygon. Why these are the convex polygon? Because here each angle is less than 180 degree. Each angle is less than 180 degree, interior angles. But here this one of the interior angle is more than 180 degree. Here these angles are more than 180 degree. One reason. Second reason, here diagonals, both the diagonals are, here all the diagonals are interior. All the diagonals are interior, but here one of the diagonal is exterior. Here these diagonals are exterior. So this is a concave polygon. These are the concave polygon and these are the convex polygon. Polygons may be regular and may be irregular. So which are the regular polygon? Regular polygon means it must be equilateral and also equiangular. That means all the sides must be equal and all the angles must be equal. So in triangle, equilateral triangle, all the angles are also equal and all the sides are also equal. This is the regular polygon. Now square is a regular polygon because all the sides are equal and all the angles are also equal. In irregular polygon, let us take one example, rectangle. All the angles are equal, this is equiangular, but this is not equilateral because all the sides are not equal, only the opposite sides are equal. So this is not a regular polygon. If you are taking a rhombus, all the sides are equal, but all the angles are not equal, only the opposite angles are equal. So these are the irregular polygon and these are the regular polygon. To be a regular polygon, it must be equilateral and also equiangular. Now let's discuss about the diagonals of polygon. What do you mean by diagonals? Diagonals means the line segment which join the non-consecutive vertices of a polygon. These are the line segments which are joining the non-consecutive vertices. But how to know that how many diagonals a particular polygon has? So what is the formula of number of diagonals in a polygon? That is equal to n into n minus 3 divided by 2. Why it is? Let us take one pentagon. Here you know that in any polygon number of sides equal to number of vertices equal to number of angles. So here if we are taking the number of diagonals, and diagonal means the line segment which is joining the non-consecutive vertices. This is one. From here 1, 2, 3, 4, 5 number of vertex are there. From one vertex we can join 3 and 4. We cannot join 1 and 2 because 1 and 2 is a side knot, it is not a diagonal. From 1 to 3 we cannot join, 1 to 5 we cannot join because this is also a line, and 1 to 1 we cannot join because this is the same vertex. So from a particular vertex we have to subtract 3, that's why n minus 3. And n into n minus 3 because every vertex has, we can draw from every vertex one diagonal. From vertex 2, from vertex 3. But are you observing when we are taking 1 to 3, we are joining 1 and 3 and 1, it is repeating. That's why it is divided by 2. So the formula of number of diagonals in a polygon equal to n into n minus 3 divided by 2. So what is the number of diagonals in a pentagon? So n means the number of sides in a pentagon, in a polygon. So here in pentagon n equal to 5. So here in pentagon it is 5 into 5 minus 3 divided by 2. That is equal to 5 into 5 minus 3 is 2 divided by 2, that is equal to 5. So in a pentagon how many number of vertices are, how many number of diagonals are there? 5. In this way by using this formula we can find the number of diagonals in any polygon.